We are going to be working to complete the FET waves on the string, but while the sunlight is shining in here, I wanted to show you our radiometer. Kids later in the day, we don't get sunlight coming into the room, so we can't see this. Now, if I block the sunlight, if I block the energy, you can see the little, what looks like a windmill in there, starting to slow down. What happens is this bulb, it looks like a light bulb really, has had all the air pulled out of it using a vacuum. There is a needle pointed up into what looks like a tiny upside down test tube, and that test tube is providing a very low friction contact with that needle. Now, one side of the fan blade is black and one side is white, and when we let the sun hit this, the black side absorbs the sunlight and the white side reflects the sunlight. For the most part, they both reflect and they both absorb. But the sunlight energy, the waves from the sun, actually push this vane. There's no electricity, and it's kind of fun to watch for a minute, but it's hard to demonstrate when the sun isn't blasting through the windows. Okay, so we're going to leave this over here. Let's get back to what we started yesterday. You got a worksheet. Woohoo! You got a worksheet with an address that didn't work for everybody. So the easiest way to do this is just to type this into your search bar. That should be the first thing that pops up. And you went in and you adjusted the frequency on waves and you measured the wavelengths. Now there's a couple things that are going to make this a simple process. If you go to the top, there are at top and bottom, there are boxes to check. You need to check no end, ruler, oscillate, high tension, and low damping. That's going to give you a wave shape a lot like this. Actually, a lot better than that, but it's going to be a nice and smooth, even distance between the wavelengths. And if you adjust the amplitude, you'll be able to make this wave go high enough to actually touch the ruler. So several kids were like, how do we measure this wavelength? Well, by definition, we said that a wavelength is the distance between one crest and the next crest, or the crest on the next wave. And it doesn't matter if you want to go left to right or right to left. You could also measure the distance between the troughs if you wanted to. You could measure the distance between where one wave crosses the resting state and ends up at the next part of the resting state. But the crests seem to be the easiest on this one because they actually get up next to the ruler. So what you're going to do is you're going to find the difference between where one crest hits the ruler and the other crest hits the ruler. So this one lines up with 4.6. This one lines up with approximately 7.1. And so we have to find the difference. So 7.1 minus 4.6 is 3.5 centimeters. So in this case, the wavelength would be 3.5 centimeters. Now, if you know the distance between these two crests, you should be able to assume that the distance between the next two crests would also be 3.5, and the distance between the troughs would be 3.5. So you can use a lot of methods to measure this, but I think this is probably the simplest way to get your measurements. Don't forget these settings. All right, let's take a look at what we're going to be doing with this data. So on a graph, the X is the cause and the Y is the effect. So you are in control of the cause. You are changing the frequency by using the little slider at the bottom, and you're measuring the wavelength. We always measure our results. So you're going to then get this sheet of paper and copy your data onto this T-chart. This is exactly the same thing. The x-axis has already, or x values have already been copied down there. Your measurements will go on the y. Take a few minutes, write your definitions for these terms. You don't have to have a textbook definition. Matter of fact, you could even draw pictures to define these terms. But I want to talk about independent variable and dependent variable. Let's zoom in a little bit. All right, from math class, you talked about the x-axis and the y-axis. Well, in science class, we always put the independent variable on the x and the dependent variable on the y. So I've set up this for you. I won't be doing this in the future, but the frequency that you're in charge of is your x, and it is the independent. is the independent variable. This is what you're in charge of. You change the frequency and you measure the wavelength. So the wavelength depends on the frequency. So this is the dependent. And in our class, our graphs will always be set up this way. The X is always going to be the independent and the Y is the dependent. So take your data and chart it using the numbers on here. Be careful. Don't not use your data. Okay. I'll be coming around to help.